Now we're going to consider applications of systems of equations. So we're going to look at situations that we can make two or possibly three linear equations that describe the situation, and then we'll solve it. All right, so an example like this is the following. So the sum of two numbers is 32. One of the numbers is 4 less than 5 times the other, and we want to find the two numbers. So how do we set up this situation? So the sum of two numbers is 32. So let's call one of the numbers x and the other number y. So the sum of those two numbers is 32. One of the numbers is 4 less than 5 times the other. Okay, so one of the numbers, say x, is equal to, so one of the numbers, let's say that's x, is 4 less than 5 times the other. So 5 times y minus 4 will be x. All right. So now we have this system and we want to solve that. Well, it's already kind of set up in a nice way where we could just use substitution. Of course, you could use elimination if you wanted to, but here we already know that x is equal to 5y minus 4. So let's just substitute that right into the first equation. And so what would we get? So this first equation would become 5y minus 4 plus y is equal to 32. So then we have 6y minus 4 is equal to 32, and we can bring the 4 over here by adding. Right, so add 4 to both sides and we have 36. Divide both sides by 6, and y is 6. So what would x be? Well, x is 5 times 6 minus 4. So substituting back into this equation here, so this would be 30 minus 4, which would be 26. So x is 26. Which means that we can really just say the two numbers are 6 and 26. Right? There's no real need to, designate them x or y. That was arbitrary to begin with. But what are the two numbers, 6 and 26? Let's say that Amy has 15 coins totaling $2.70, and the coins are quarters and dimes. How many of each coin does she have? So we're talking about quarters and dimes here. So let's say that Q is the number of quarters, and D is the number of dimes. Then what is Q plus D? Well, the number of quarters and the number of dimes, we know that there's 15 coins, so there's in total 15 of them. But how do we make an equation that gives us this information with the cost? Well, a quarter is 25 cents. So 25 cents times the number of quarters will give us the value of the number of quarters, and then 10 cents times the number of dimes will give us the value of the dimes that we have, and that should be $2.70. So now we have two equations that are linear and they have Q and D in them, and now we want to solve this, right? So solve this system. Solve that system. Well, we could use a similar technique to above. You could do a substitution method. You could solve for, say, Q or D and substitute into this. But just to change it up a little bit, let's try a elimination method. So let's say we want to eliminate Q. Well, we could multiply the first equation by negative 0.25 so that we match these coefficients. So negative 0.25 times Q plus D equals 15. And then the second equation we would leave the same, right? So what would that give us? So that would give us negative 0.25 Q, negative 0.25 D, and then negative 0.25 times 15, which is negative 3.75. Okay, and then the second equation is 0.25 Q plus 0.10D is equal to $2.70, or 2.70. So now let's add these two equations. So if we add these, you see that the Q is eliminated, but then we're left with negative 0.15D, and then adding negative 3.75 to 2.70, we will have negative 1.05. 0.05, and so then we divide both sides by 0.15, well, negative 0.15, and so that'll give us the number of dimes. So now D will be, this will be 7. So the number of dimes is 7. So how do we figure out Q? Well, you just come back up here to one of our original equations and substitute this information. So Q plus 7 is equal to 15. So that means Q would have to be 8. So number of quarters is 8. Number of dimes is 7. And you can always check your answers in the end. Yes, that's 15 coins, and number of quarters would be $2, and that would be 70 cents. So that's actually a pretty quick check. Now let's say that 3 candy bars and a soft drink cost $1.80, and in the same store, a single candy bar and a soft drink cost $1.10. So let's find the cost of each of those items. So let's say that C is the cost of a candy bar, and S is the cost of a soft drink. So what do we know? The 3 candy bars and a soft drink cost $1.80. So 3 candy bars and a soft drink is $1.80. And in the same store, a single candy bar and a soft drink is $1.10. And we want to solve that system. Okay, so solve that. Well, what could we do? We could do either an elimination method, or we can do substitution. Doesn't really matter what method you want to use. Maybe since we just did elimination method again, maybe we could try substitution, right? Okay, so what would we be able to do? We could say C is $1.10 minus S, and now sub into equation 1. Let's say that this is equation 1 and this is equation 2. So then we would have 3 times this plus S is equal to $1.80. Okay, so then we would have $3.30 minus 3S plus S is equal to 1.8, and then we would have 3.30 minus 2S is equal to 1.80. So we could add the 2S over here. And then we would subtract the 180 from both sides, and we get $1.50 for 2 soft drinks. So divide both sides by 2. 150 divided by 2 is S, so that is 0.75. So a soft drink will be 75 cents. And then how do you figure out the candy bar? Well, we could substitute into this one here. So a candy bar is this minus 0.75. So C would be 35 cents. Okay, so soft drink would be 75 cents. Soft drink. Candy bar, 35 cents. Okay, so now let's say that Bob invests $12,000 in two accounts. One is paying 5% interest and the other is paying 7% interest. The total interest paid by the two accounts at the end of the year is $800. And we want to find the amount invested in each account. Okay, so we're split between these two accounts, right? So account A and account B. So A is the amount in account with, let's say, the 5% interest, and B is the amount in account with 7% interest. Okay, so we know that the sum of the two amounts initially, is 12,000. And if the total interest paid by the accounts at the end of the year is 800, then we can find the amount invested in each of these accounts. Okay, so how do we do that? Well, we know at the end of the year that's $800, and how do we determine that? Well, we are getting the 5% from A, so 5% from A, and the 7% from B. And now we have this system that has A and B, and we want to solve this. Okay, so what could we do? Well, we could do an elimination method, right? So let's say for equation 1, let's multiply this first equation by negative 0.05. So equation A, if we multiply by negative 0.05, what do we get? Negative 0.05A minus 0.05B equals negative 0.05 times 12,000. And then equation 2, so this is sort of like 1 modified, right? And then equation 2 we'll just leave alone. And then we're going to add these, right? So what do we get? We will get the A's cancel, right? But then we're left with positive 0.02 for B. And then what is this going to be? This is 600. Or sorry, negative 600, right? Because there's a negative in front of here. And then adding these, we'll have a positive 200. So then divide both sides by 0.02. And then B is 10,000. And then A would be 12,000 minus B from equation 1, which would be just 2,000. Okay, so since I originally labeled what A and B are at the top, I could just box this. Okay, if we didn't explicitly write out what A and B were, then it's a good idea to rewrite your answer in general. So let's say that a company has fixed costs of $100 per week, and the variable cost for each item that they produce is $10. And if the company sells each of these items for $12, find the number of items the company would have to produce and sell to reach the break-even point. So revenue would be equal to the total cost. So what is the cost function here? So the cost for producing each item, so the cost for producing X items is equal to what? So a company has a fixed cost of $100 per week. So producing X items, per week. So the fixed cost would be 100, but then for every item that's produced, there was a variable cost of $10. So that's going to be 10 times X. Okay. So that's the cost of producing X items per week. And then what would the revenue be? Well, anytime that one of those items is sold, it'll add to the revenue, right? So the revenue selling X items per week would be 12x, right? And so the question is, well, how many items need to be sold to reach the break-even point? So break-even point is where these two would be equal. So we'll just set them equal to each other. And we can just solve, right? So subtract 10x from both sides. We'll have 100 equals 2x. So then divide both sides by 2. And so we'll have x is equal to 50. So 50 items to break even. Jared was selling tickets to ride the Ferris wheel at a local carnival. The tickets cost $2 for adults and $1.50 for children. How many of each kind of ticket did he sell if he sold a total of 300 tickets for a total of $525? Okay, so let's say that A is number of adult tickets sold, and C is number of child tickets sold. So what is A plus C? So the total number of tickets was 300, but an adult ticket was $2. So 2 times A will be the cost of, that'll be the total cost of how many adult tickets were sold. And 150 times the number of tickets sold to children will give us the total cost of 525. So now we have this equation that we want to solve. And we can use any method that we want. So we could use elimination method, for example. And what could we do? So equation 1, we could multiply by -2. Giving us, so -2a minus 2c is equal to -600. And so this would be sort of our modified equation 1. And equation 2, putting that here, we'd have 2a plus 1.5c is equal to 525. We can add them now, right? Add these two equations together. And the a is eliminated. And for c, we will have -0.5c is equal to -75, and then we just divide by 0.5, -0.5, sorry, whoops. And then c would be positive 150. So the number of child tickets sold to children would be 150, which would mean that A plus C is 300. So A plus 150 is 300. So subtracting 150, A is also 150. So that's it. So A is 150 and C is 150. So the number of adult and child tickets was the same, and it was 150 for both. Okay, and now for our last example, let's say that a boat on a river travels 20 miles downstream, so with the current, in only 2 hours, and it takes the same boat 6 hours to travel 12 miles upstream against the current. And what are the speed of the boat and the speed of the current? So what's the speed of each of those things? So if you read this section in the book, example 5 is a very good model and has a good strategy for this. So the equation that we're going to use here is, so distance, and in this case it's in miles, is, so we could call that D, is going to be equal to the rate times the time. So this is usually R and T, and so then the rate would be in miles per hour and the time would be in hours. Okay, so that's sort of the general equation that we're using. Distance is rate times time, or speed times time, right? But when you're going upstream and downstream, then we have some variables that we're going to introduce. Okay, so what is the total distance going upstream? So it was 12 miles, and going downstream was 20 miles. All right, and here's where we're going to introduce the variables. So the variables are introduced in the rates. Okay, so let's say let x be equal to the speed of the boat let's just say in still water. So let's say that there's no current, supplying any additional speed or taking away the speed from the boat. So just the speed of the boat, plain and simple, and let y be the speed of the current. Then if you're going upstream, then you're going to take the speed of the boat and you're going to take away, the current is going to take away some of the speed, right? So you're going upstream is going to be harder, right? So x minus y will be the rate. Downstream, the current is going to add speed to the boat. So you would add these two, right? So if you're going with the current, then you would add the speed of the boat and the speed of the current. If you're going upstream, then you're going to take the speed of the boat and we're going to have to subtract the speed of the current, okay, because it's going to be slowing it down. And going downstream, it only took 2 hours, but going upstream, it took 6 hours, right? So the strategy is you can kind of fill in this little chart here, but you're getting equations, right? So this is actually your equations. Okay, so let's solve this system then. So what do we actually have? We have 12 is equal to, so distributing that 6, so we have 6x minus 6y, and 20 is equal to 2x plus 2y. And now you can solve this problem using any of the methods that you want. If let's say we want to eliminate the y variable, since we already have this negative here, we could multiply this equation by 3, and what would we get? So we get 12 equals 6x minus 6y, and then this second equation, right? So this is equation 1, this is equation 2. Equation 1 and modified equation 2 becomes 60 equals 6x, so distributing the 3, plus 6y. And now we can add. So we have 72 is equal to 12x, and the y's are reduced here. So then we divide both sides by 12, and we get 6 is equal to x. All right. So then what do we get for y? So now we have determined the speed of the boat, right? But what's the current speed? Well, you can plug that into either of these equations, right? So we could plug it into the first equation there, and we would have 12 is equal to 6 times 6 minus 6y. So 12 is equal to 36 minus 6y. And we could add the 6y over here. And then we could subtract the 12 over here. And so we have 6y is equal to 24. So then divide by 6. And we have y is equal to 4. Okay, so speed of the boat. In still water is what? That was x, so it's 6 miles per hour. And speed of current was 4 miles per hour.